Here we have another important probability rule that involves conditional probability. It's called the multiplication rule. The multiplication rule says that the probability that two events A and B will occur in sequence, so that's in order, is P of A and B is equal to P of A times P of B given A. And though the word is not there, because of the word sequence over here, this is essentially saying the probability of A and then B occurring is the probability of A occurring times the probability of B occurring, given that A has already occurred. Let's look at a couple of examples. What's the likelihood of getting 3 tails when flipping a coin 3 times? Well, that's technically the probability of getting a tails, and then a tails, and then another tails, using T to represent tails. Now you might look at this and say, well, this only involves 2 events, this rule. And that's true, but if we know the events are independent of one another, we can generalize this to any finitely many events. So for example, if you know that A, B, C, and D, let's say, if you know all of them are independent of one another, then the probability of A and B and C and D would simply be the probability of A times the probability of B times the probability of C and times the probability of D. So if you know these are independent, so I'm making the assumption here. Notice if you know they're independent, then the conditional probability drops off. There are no conditional probabilities here. So if it's independent, you can break it up like this. And since each time you flip a coin, it's independent of the previous flips, so we can change this to the probability of getting the tails times probability of getting the second tails times the probability of getting the third tails. And each time you have a 1/2 chance. So you get 1/2 times 1/2 times 1/2, giving you a 1/8 chance of getting exactly 3 tails when you flip a coin 3 times. Now, in example 2, what's the likelihood of getting dealt 2 aces when dealt 2 cards? Now, if you're not completely familiar with the deck of cards, we will go much more in depth into that in the next video when we discuss the addition rule. Just for now, know that there are 52 cards in the standard deck, and 4 of them are aces. 4 of those 52. So what's the likelihood of getting dealt 2 aces when dealt 2 cards? That's the same thing as technically getting dealt an ace and then another ace. So if you wanted to, ace 1, ace 2. Could have done that up here as well. Tails 1, tails 2, tails 3. Don't need it. Could have definitely put that in there if I wanted to, though. But the probability of ace 1 and then getting another ace. Well, when you pull one card, the likelihood of getting ace 1 is 4 out of 52 times, remember, we simplified this over here because we assumed they were independent events. This second ace is not independent of the first ace. Once you've drawn that first ace, what happens? Well, there's only 51 cards left. And assuming that you got the ace, there's only 3 aces left. So the likelihood of then getting a second ace is only 3 out of 51. So in this case, these 2 events were not independent of one another, meaning we were using this formula here. While the multiplication rule is valuable in computing probabilities of events occurring in sequence, it's also valuable in that we can define conditional probability based on that. So in the previous screen, we saw the probability of A and B is equal to the probability of A times the probability of B given that A has occurred. This is the multiplication rule. If we do some basic arithmetic and divide both sides by P of A, assuming P of A is not 0, then we get this new formula. Probability of B given A is equal to the probability of A and B divided by the probability of A. So if you ever wanted to compute a conditional probability, you can find the probability of the conjunction of them divided by the probability of this guy A here. Make sure you realize that this A is the given condition in the back.